The current understanding is that the universe began with the Big Bang, followed by an exponential expansion phase known as inflation. Those who think 93 billion light-years wide is vast should know that this is just the observable universe. Beyond what we can see, it potentially extends infinitely. The James Webb Space Telescope, combined with the intellect of thinkers like Roger Penrose, is pushing the boundaries of what we know about our incredible universe. When discussing the universe's enormity, we often refer to the observable universe, the part we can see from Earth. Light, traveling at the fastest speed known, still takes time to reach us. The universe is approximately 13.8 billion years old. So when we observe distant objects, we're seeing light that has traveled for billions of years. If something is further than 13.8 billion light-years away, we can't see it because its light hasn't had time to reach us. The observable universe appears like a giant bubble around us, with light traveling up to 46 billion light-years in any direction. This is due to the universe's expansion since the Big Bang. Hence, objects that emitted light 13.8 billion years ago are now much further away. This gives us an observable universe 93 billion light-years in diameter, containing at least 2 trillion galaxies, each with billions or trillions of stars, planets, and other objects. The universe isn't just composed of visible matter, it includes dark matter, which we can't see but know exists due to the way galaxies move. There's also dark energy, causing the universe to expand faster. Additionally, the cosmic microwave background, CMB, is a faint radiation glow from the Big Bang. Tiny particles called neutrinos buzz around, barely interacting with anything. But they exist, as evidenced by redshift, the stretching of light to longer wavelengths as the universe expands. The universe is like a grand cosmic show, but with a delay. When we observe a star 10 light-years away, we see it as it was 10 years ago. The further away an object is, the older the light we see. This allows us to look back in time, almost to the beginning of the universe, by observing distant objects. The sun and moon, though seemingly close, are quite distant. The sun is about 150 million kilometers, 93 million miles, from Earth, a distance known as an astronomical unit, AU. The Earth orbits the sun in an ellipse, not a perfect circle, bringing it closest to the sun, perihelion, at about 147 million kilometers, 91 million miles, in early January, and farthest, aphelion, at about 152 million kilometers, 94 million miles, in early July. The average distance to the moon is 384,000 kilometers, 238,000 miles. Proxima Centauri, the closest star to the sun, is about 4.25 light-years away. Light from Proxima Centauri takes 4.25 years to reach us. This star system has at least 2 planets, one of which may lie in the habitable zone where conditions could allow for liquid water. Moving beyond our local neighborhood, the Milky Way galaxy is about 100,000 light-years across. We have never seen a true photo of the entire Milky Way. The images are artists' impressions or photos of similar galaxies. The Milky Way contains between 100 and 400 billion stars and at least that many planets. At its center is a supermassive black hole known as Sagittarius A*, with about 4.1 million times the mass of the Sun. The nearest large galaxy to the Milky Way is Andromeda, about 2.5 million light-years away. The local group, our galactic neighborhood, contains over 20 galaxies spread across 10 million light-years. This group includes the Milky Way, Andromeda, and the Triangulum Galaxy, M33. The local group is part of the Virgo supercluster, which spans 110 million light-years and contains over 100 galaxy groups and clusters. The Virgo supercluster is part of an even larger structure called the Pisces-Cetus supercluster complex. Our local supercluster is moving towards a region in space known as the Great Attractor, an area with an unusually strong gravitational pull. Recent discoveries suggest the Virgo supercluster is part of an even larger structure called Laniakea, meaning immense heaven in Hawaiian. Laniakea, our cosmic home, contains about 100,000 galaxies and extends over 520 million light-years. It has a mass of about 100 quadrillion times that of the Sun. Laniakea is part of the larger Pisces-Cetus supercluster complex, a massive array of galaxies spanning the universe. This structure was mapped out in 2014 by astronomers who used galaxy movement to identify superclusters. They mapped out the flow lines and gravitational centers, defining the boundaries of Laniakea. The Hubble Space Telescope and the upcoming James Webb Space Telescope, JWST, provide most of our knowledge about the universe. Hubble, in orbit since 1990, captures stunning images and data in visible, ultraviolet, and near-infrared light. JWST will help resolve the Hubble constant discrepancy by providing more precise measurements of cosmic distances and the universe's expansion rate. JWST can observe standard candles like certain types of supernovae and quasars to measure distances. It can also use gravitational lensing to determine distances, helping us better understand the Hubble constant. Additionally, JWST will employ cosmic chronometers, such as old stars or galaxies, to estimate the universe's age and expansion. Our understanding of the universe's size, growth, and history will improve significantly with JWST. It might even provide insights into cosmic cycles and the history of the universe. Do you think the universe is infinite? Share your thoughts in the comments and stay tuned for more mind-blowing videos.